Today, we're getting an inside look at the true pace of AI progress. We're not talking about headlines here, we're talking about the perspective of the researchers who are actually building this stuff day in and day out. And let's just start with this quote from an OpenAI researcher. It just nails the feeling inside these labs. For them, this isn't just hype. The speed at which this technology is evolving is, in their own words, absolutely amazing. So to really get a feel for where we are right now, we gotta look back at how far we've come, and honestly, it's been a wild ride. Okay, look at this. It seems so simple, right? This movie's not bad. A decade ago, the best AI models would read that and think, oh, the word bad's in there, it must be negative. They completely miss the nuance. But today's models get it instantly. That little leap in understanding context and subtlety, that's a giant leap for AI. And this progress wasn't a slow crawl. It happened in these huge, explosive jumps. I mean, back in 2019, when GPT-2 could write a single coherent paragraph, that was mind-blowing for the researchers. It was a massive breakthrough. Then, fast forward just 4 years to GPT-4, and it's so good it's actually surprising the people who made it. One researcher even called it their personal AGI moment. That's the point where the machine starts to feel like a real general intelligence. All right, so let's jump to a really recent milestone. For years, researchers have looked at this next challenge as a key stepping stone, a huge benchmark on the path to AGI. We're talking about the International Mathematical Olympiad, the IMO. This is not your standard math test. This is the world championship for the brightest young mathematical minds on the entire planet. The problems are designed to test pure creativity and reasoning, not just plugging numbers into formulas. So here's what's so incredible. An AI model reached a gold medal level at this competition. And it didn't do it with a calculator, it didn't brute force its way through, it did it with pure mathematical reasoning. It showed the kind of creative, out-of-the-box thinking that these problems are famous for, a skill that just a few years ago was purely the domain of human ingenuity. But this might be the most impressive part of the whole thing. It solved the first 5 problems. But when it got to the legendary problem 6, which is notoriously difficult, the model did something amazing. It recognized that the problem was beyond its reach. I mean, knowing your own limits, that's a profound kind of intelligence right there. But this huge success actually created a really fascinating new kind of problem for the entire field. I mean, think about it for a second. If your AI can now ace the very tests you designed to see how smart it is, what do you do next? How do you measure progress? Does that test even tell you what you think it tells you anymore? Yeah, there's a name for this. Researchers call it benchmark saturation. The old yardsticks, the old tests, they're just not cutting it anymore. So the goalposts have to move. The new focus is shifting away from just getting a good score on a test and toward measuring real-world usefulness and, even more important, the ability to discover things that are completely new. And that, of course, leads us to the next great frontier. The game is no longer about solving problems we already know the answers to. It's about finding answers to questions we haven't even figured out how to ask yet. So the mission has changed. The new grand challenge, the real holy grail, is to build an AI that can automate the very engine of scientific discovery itself. And just listen to this quote from OpenAI's Jakub Pachocki. He's saying it's possible to build a machine that doesn't just process data, but one that comes up with ideas that could fundamentally change how we see the world. That's the ambition we're talking about here. So where do you even start with something that big? Well, they're aiming it at some of our most complex fields, like medicine. But, and this is really interesting, they're also pointing it at AI research itself. The idea is to have AI help us build the next generation of AI, making it better and, crucially, safer. Now, to get there, one of the key breakthroughs they need is something called model persistence. The best way to think about it is letting an AI just think, letting it work on a single, really hard problem for days or weeks or maybe even longer, using a ton of computer power to go deep, kind of like a human scientist does. So, with everything moving this fast, it raises a pretty big question, right? What does this mean for the rest of us? What skills are actually going to matter in a world like this? Well, the advice from the people literally building our future is really direct and maybe a little counterintuitive. They say, you should absolutely learn to code. But wait, why? If AI can write its own code, why should we? Well, it's not about competing with the AI. It's about what learning to code does to your brain. It teaches you a kind of structured intellect, a rigorous, logical way of breaking down huge, complicated problems into small, manageable parts. And that problem-solving mindset, that's a human skill that's going to be more valuable than ever. And that brings us to the final and maybe the most important question of all. We're not just talking about getting a faster computer. We're talking about fundamentally accelerating the engine of discovery itself. So, what does a world even look like when the pace of change starts to accelerate? That's the question this progress is forcing all of us to think about, because that future is coming at us way faster than any of us ever expected.